Hello and welcome. We're going to look at some tables problems, and over the course of this, I'm going to try to set up a way that makes this make sense as far as trying to use this as a resource and trying to see what's going on here. I'm going to start off by taking a look at what we can get from the question before we even begin, and then on subsequent pages talk about different parts of this problem. Starting off, I'm going to take a look at what we're given. So we've got a rate of fuel consumption, gallons per minute, is recorded during airplane flight. We've got twice differentiable. Okay. That means that the fuel consumption equation is going to be differentiable, and whatever equation we get from that is going to be differentiable as well. Strictly increasing function r. So that talks about how we have a function that will only ever have a positive derivative. Alright, we've got a graph of r, cool, and a table of selected values for r of t. And this is for some interval. Alright, so since we've got a table, since we've got a graph, and some words to go with this, but no equation, to me it sounds like we're going to have to deal with some RAM stuff. We've got a rate being given to us. That means we'll probably have to deal with some accumulation stuff, and that, to me, speaks of FTC. Part A, we're looking at the data in the table, so it tells us where to look, and we're looking for r prime of 45. Since we're given r of t, finding r prime of t is going to be based on the derivative at 45. In other words, the slope at 45. We don't have any information for 45, so what I'm going to do is get as close as possible. And knowing that if we think about this in x's and y's, my x's, my inputs, are going to be my t, and my outputs, my y values, are going to be my r of t. So if we're talking about the slope here, we're going to have 50... Sorry, I've got a not great stylus. 55 minus 40, and that's my y values. It's also an overactive guard dog that you'll hear every so often if I don't stop the video in time for him flipping out at a car going by. And then I need my x values. That's going to be 50 and 40. This is a little bit confusing because we have similar x values and y values. And once you do this part, interestingly enough, you don't have to go any further with the math. If you'd like to go further, we're going to have 15 on top and 10 on the bottom. That's going to be 1.5 if you so choose. And in terms of units, we've got gallons per minute being subtracted on top, minutes on the bottom. So I could write this as gallons per minute, or I could write this as gallons per minute squared. Either one is okay for me to do. Okay, part B. Here we're being told that the rate of fuel consumption is increasing. Okay, so our equation is rate of fuel consumption when we're increasing fastest. Oh, so that's like saying that r prime has a max at t equals 45. So to me, since we're talking about twice differentiable function, that means that r double prime should be changing from positive to negative at this point. If I can spell changing right. So changing from positive to negative. And if we take a look at that idea, that means that r double prime must be 0 at that point, because this is twice differentiable, since R is twice differentiable, that means that R double prime is continuous, because R prime has to be continuous and differentiable. And then going down another layer, we have to have all those values exist as well. This means that we can't have some kind of an asymptote here, but rather R prime must be 0. Or sorry, R double prime must be 0 at this point. In part C, as we are predicted, we have to do a left Riemann sum. This is kind of awkward because the table is given to us up and down instead of sideways, so it might be helpful for some of us to rewrite this going like, I'm still on move mode, 0, 20 for my first x and y values, and then we're going to have 30, 30. This is totally not necessary, but it might be a good way for you to process what's going on here. 40, 40, and then we're going to have 50, 55. We're going to have 70, 65, and 90, 70. Okay, so for a left Riemann sum, we need our first width, which is going to be 30, times the left value 20. And then we need our second width, which is going to be 10. And our second value is going to be 30. We need our third width, which is also going to be 10, multiplied by our third value of 40. We need our next value of 20, and that's looking at a value of 55. And then finally, we need our last value of 20. And our last left value of 65. Alright, so this is our left Riemann sum. This should be in appropriate units, and if we're multiplying gallons per minute by minutes, that's going to be gallons, although we're not asked for that in this problem. And then we've got to decide if this is less than or greater, or I guess, is this less than the actual value? Okay, so just to think about this, a left Riemann sum uses the heights at the left of each interval. This graph is a nice visual way for us to see what's going on here, but this is not allowable as far as evidence on your AP test. And the reasoning for this comes from what we mentioned at the beginning. We have a strictly increasing function. Since r of t is strictly increasing, so we're talking about something that's increasing. Left, I'm just going to call that LRAM because this is hard to write with, is an underestimate. For part D, now we're looking at a couple of weird written things. So if we're talking about going from 0 to b of r of t dt, which is what we just approximated going from 0 to 90, I think this is a really good place to think about what we're doing here. We're multiplying minutes by gallons per minute, and the answer for this is going to be in terms of gallons. So this would be something like the total amount of fuel and that's going to be in gallons. Like that, I'm speaking way faster than I can write. So the total amount of fuel consumed between t equals 0 and t equals b. So that could be the first b minutes of the flight. That would make sense. And then the other part of this is explaining the meaning of 1 over b r of t. So this is an average value thing. And here we're looking at the average value of r of t over the interval from 0 to b. And in terms of that, that would be the average fuel consumption, because that's what we're looking at as r of t. And that's going to be in gallons per minute. Looking at this problem as a whole, we're taking a look at doing some approximations of derivatives. That's really finding an average rate of change. We're dealing with processing kind of the graphical analysis of things. That's dealing with what does it mean to be the second derivative, and how does that compare to the first derivative. We're given a rate function, which is a little bit unusual in the first place because we're used to dealing with equations that determine a quantity, and the rate is the derivative. And then we're given some RAM stuff, and then really what we're doing is, this is an FTC question about how much we have consumed or how much we've accumulated over a given time, and asking you to interpret the meaning of an average value thing. All these are a little bit unusual in terms of they're not the way that we think of questions being asked, or at least most of them are, because we're being asked to interpret things more than we are being asked to solve problems. Looking at the rubric for this, a couple things that I'd like for us to note. You must include a difference quotient. That means you have to include something going on here to show that you're finding the actual slope. The other piece is that you could stop as soon as you've substituted numbers in. This is a way that we do not accidentally subtract funny and get, 75 when we do 55 minus 40. The other piece is that the units must be included here. The second part of this talks about the important thing that they're really looking for is the idea that r prime has a maximum, and that's why we're dealing with r double prime is equal to 0, but we went a little bit further in as far as our explanation. Third part, you need the value of the left Riemann sum. That happens here. And you need less with some kind of a reason. It's enough there to say r is increasing, as long as you answer the question. Going from 0 to b, total amount of fuel consumed for the first b minutes. We talked about that. The average value of the rate of fuel consumption in gallons per minute. Cool, we talked about that. -1 if you don't actually refer to b in these. Then we get a point for the units in both those answers.